going to kind of talk about, like an analogy, the crest of a wave, and a little bit about water-based inks and how really they're finally reaching their place in the market, and the time is now really for aqueous printing. Very, very short bit about Sun Chemical. Obviously, Sun Chemical's a pretty sizable ink provider, both digital, analog, also pigments and coating solutions around the world. But let's talk about that. So when I was thinking about what to talk about and the water-based, I wanted to kind of address some of the whys. Why is water-based something now that's got such a pull from the market? Why are so many people asking for water-based solutions? Why water-based? Why now? And a bit like, why has it taken so long to get to this point? Because frankly, it has. We all expected the water revolution to probably happen about 10 years ago. I think Andy mentioned yesterday that pigment for textiles is a thing that we all expected 10 years ago, and even now it's not really getting into the market in the way. And why has it been so challenging? And a bit then about how we can start to successfully implement water-based technology in some pretty industrially challenging applications like packaging. So why water-based? I mean, water-based inks are nothing new, right? They're probably the first inks that were developed for your small office printers. But in terms of their relevance now, they've long been perceived as a more environmentally friendly or sustainable option. Many of the people that want to address sustainability challenges in their business just come to ink companies like ours and say, we only want to talk about water-based. So you try and talk to them about solvent or UV, which may not only interested in water-based. And there's this perception, things like they're low odor, right? Solvent smells, UV's a bit smelly, so water's perceived as more friendly. This perception that they're low VOC, not always accurate, by the way, but there's in the minds of many of the brands and print houses, that's true. And what's really started an acceleration is the regulatory updates, the need for compliance, especially in areas like food packaging, where things have changed, regulations have changed, government standards are being brought in. That means that using some other technologies are more challenging. That leads into the food packaging requirements. There's also a strong perception that water-based is cheaper, right? So if you've got a fluid that's 70% water, there's an expectation that that's a pretty low-cost solution, and that's another potential driver for that. But it also, there's a big improvement and surge, and I think we're going to talk about some of that afterwards, of materials that we can use in water-based, pigment dispersions, resins, things that are now available to formulators that weren't previously. And there's also this benefit of water-based that it produces, once you've evaporated and dried off all the water, produces a very thin film of concentrated color at the surface of many substrates, whereas UV and other technology is 100% solids and may build more of a profile, and different applications prefer that. So some of the trends that have led to this, so substrate evolution is one, especially in the food packaging area where people are looking at use of plastics, the switch to monomaterial, single plastic substrates, the higher recycled content, so that means that barrier layers are not becoming a thing of the past, but less common, and so it's a little bit more challenging for UV inks. Recyclability and de-inking in terms of regional legislations, there's a lot coming in, and there's a perception that water-based inks in some cases are easier to de-ink, easier to fit into that recycling chain. What's made water-based more suddenly, not suddenly, but the amount of collaboration on water-based. So UV is such a well-known technology, instant drying, very easier to manage on a print head in terms of its evaporation, open time, nozzle clogging. And then when you think about water, it's much harder to dry, but it dries quickly in the nozzles. And so actually the collaboration between material suppliers, ink makers, press software, that kind of environment has allowed it to flourish now. And those regulatory aspects that I mentioned. So I took a step back and thought about what I saw at Drupa, and it felt like it was a breakthrough for water-based at Drupa this year. A lot of key OEMs were there showing primarily aqueous technology in applications that hadn't been showing water-based solutions before. And you may think, well, there's been an 8-year gap from one Drupal to another, so that's allowed people time. But I think if the Drupal 4 years ago had happened, there still wouldn't have been any water-based solutions there. It's really, no one was ready, even though their initial goals were for them, because it has been challenging. And one key thing was the arrival of aqueous inks for flexible packaging. I think I counted 5 single-pass industrial solutions for flexible packaging, all running aqueous inks for the first time. Some hybrid flexo inkjet with flexo whites, or flexo solid colors with inkjet for the detail, printing speeds with water-based, and drying in line up to 200 meters a minute. That's really the breakthrough. It's the print speed and being able to dry it at those high speeds in those challenging applications. But it wasn't just packaging. Other solutions and segments were there showing it: labels, wide format graphics, poster printing. There's really a surge of water-based solutions. So will water-based be replacing UV? Simple answer to that is no. In the way that will digital ever replace analog as a printing process? No. But they can sit side by side for various reasons, and they can support potentially the implementation of digital more widely, particularly in applications like packaging. Because of the compliance benefits, low or no migration, no need for metallization of films or barrier layers to the same extent. They're typically safer for users to handle on press. The durability gap has closed, so in many cases UV inks will maintain a higher durability than aqueous, but that gap has certainly closed with the access to better resin technology for aqueous systems now. The big challenge remains drying. There's no doubt, but the drying has improved a lot, whether that's IR, NIR, RF drying that you see now, hot air, or a combination of those. You start to see drying strategies that allow high-speed single-pass printing. The ease of use has got better in terms of on-printer behavior of aqueous inks. They've previously been quite challenging to manage, and they're pretty versatile. They tend to create much more flexible films, and they have those lower hazardous chemicals typically, and so for applications like food packaging, they really are a preferred choice. But surely this is nothing new, right? There's loads of industries that have been using water-based inks industrially for years. For example, textiles. Right? Textiles has had a pretty good conversion from analog to digital. We talked about 3% in packaging segments yesterday. Textiles is approaching 15% conversion, and with high-speed single-pass presses, but the substrate's way less challenging, and the perception's way less challenging in textile. There's no need for 4-point text, for reverse out text. There's no need for an image printed on a textile is very much a subjective print rather than looking at high detail. We don't need 1200 DPI. And so perhaps water-based has dominated in areas where substrate and application requirements are a bit more forgiving. And now we really need to address some of the other challenges, particularly on non-porous substrates of wetting, adhesion, color, consistency across the web, and stuff like that. So why has it taken so long? Well, it's been so many steps to get up to arrive at a point. So the substrate is key and has changed a lot. Substrates have got thinner, cheaper, use of recycled materials, which means that they're quite variable in their surface characteristics. And water-based is way more susceptible to defects on a non-pure substrate because it creates such a thin film. You can see the underlying substrate in many cases. So that's been a challenge. The drying behavior I've mentioned, it's much harder to manage than UV, and it needs a strategy by application. Some of those plastic films are very heat sensitive, so you have to work on your strategy. The durability in terms of selecting the right resins and cross-linkers and polymerization mechanisms that allow you to get a really nice surface with a highly durable print. And that's becoming critical now, which I'll talk about. The compliance needs. And one of the challenges of water-based inks is often we're dealing with new materials that aren't on any of the lists. So if you want to be Nestle compliant or Swiss Ordnance compliant. They give you a list of all the things you can and can't use, particularly that you can't. And there's a load of materials that, of course, aren't on there. So it means a whole bunch of extra testing to make sure that what you have isn't migrating and stuff like that. And then there's an education gap. There's still a perception that water-based needs to do whatever solvent-based and UV was doing, in the same way as everybody still thinks that a digital system needs to match the output of an analog system. And we need to find that balance where water-based is right in these applications and UV in these, and find its place, or find a way of maximizing the performance in the same way as digital as a whole. Like, if all you want to do is match an analog output with a digital system, you're gonna run into problems more often than not. And there's so many moving parts in digital. It's such a complex science, as we all know, right? So substrate, understanding the characteristics, the surface tension of the substrate, how the ink wets, how we get the key into the surface. So that's the first part, and normally the part that is out of control from our point of view. The ink chemistry is often expected to deliver a single solution across a range of substrates, delivering color, brand standard colors, adhesions, nice film formation, all these things. The hardware's advanced massively, but every time there's a change in a print head or a process, the ink has to adapt to meet the requirements of those print heads. So as the technology is advanced, the ink has to advance, and there's way more print heads that are robust with water-based solutions than previously, and so that, again, is accelerating the adoption. It's got to work in the workflow. We heard a lot of workflow and how you manage jobs and how long there are gaps between printing, the web to print, and the interconnectivity of the systems. But then it has to work in post-process, especially inks have to work in the post-process. So after they've been printed, the printing job's done, but there's still potentially gluing, folding, creasing, other processes that are applied to the printed film that's on that surface, so it has to be robust to that. And then in its final end user performance. And that's changing massively, whether it's ready for shelf packaging, so they don't want the outer box anymore. They want to be able to put all the packs on, wrap them in plastic, and they just go straight onto the shelf in the stores without additional packaging and waste and recycling streams. So the durability has to be better. But also things like refill packs, right? If you used to buy a big jug of detergent for your washing machine, and once you've finished it, it will go in the bin or the recycling. Now that has to last multiple times because you buy a refill and you top that up. So the print on there has to survive way longer than it ever did before. But if any one of those processes changes, the ink chemistry has to adapt. It's almost like starting again, because if you change the print head, you change the post-process, you change the performance requirements, probably you're changing the ink. And that has meant a lot of restarting projects, and that's part of the reason of the time it's taken to get there. And this perception that one size fits all, or one ink can do everything. And it's just an example. These are some flexible packaging films where you can tune an ink for a certain film, in this case a polyethylene or a PT film, with excellent print quality. These are very kind of highly zoomed images. But if you print that same ink and the same conditions on different substrates, you can see a clear OPP, a white, a clear PE, a yogurt lid paper. You don't get an acceptable result. It's completely different. And this perception that, okay, you can just make an ink for a substrate and that should work on all these other substrates is kind of the holy grail, but that is one of the stumbling blocks and the reasons that aqueous is a bit more challenging, because the surface varies so much in their porosity, in their surface energy, how the ink wets, how they're handled through the system, how much heat you can apply to them to dry it, how quickly you can do it. And all of that leads to challenges that we need to overcome. And the way we try and overcome those is by this word holistic approach, but really focusing on the customers and working with technology partners around the customer, so the press manufacturers, the converters, the packaging substrate suppliers, along with the digital teams, both ink, software, hardware, ink delivery systems. They all play, obviously, a crucial role. And those collaboration projects are really what delivered the results that we were all able to see at Drupa in terms of high-speed aqueous printing, particularly in packaging applications. So sometimes we need to take a step back and try and work out how do we simplify the process? How do we get our thinking behind delivering something on multiple substrates? And in our case, we're very lucky to have within the division a coatings group that works on priming technology. So slightly different approach to the high viscosity, but applying a very thin layer analog of a primer. It's like 3 microns, 30 to 40 micron film weight, so very, very low weight. That enables us to even out the surfaces, print on a wider range of substrates, and that's supporting digital print for packaging applications to go mainstream. So nearly all of those aqueous inkjet presses that were showing flexible packaging at Drupa were applying a primer in line before the printing, because that's how you start to overcome some of the challenges in terms of the substrate variability and wanted to print multiple products with a single ink solution. So it gives us consistent performance on print area. It closes the gap to this holy grail of a single ink that will print onto absolutely everything and work in a printer and print head and do everything you want it to do. And this has become increasingly important, as I said, in packaging applications especially. So why would we prime? So this is just a very simple example of 3, again, flexible packaging substrates printed with the same ink with and without primer in the same conditions. And you can see that the primer enables a wider range. So without the primer, we get a lot of dot spread, uncontrolled wetting, inconsistent drop placement accuracy, and with the primed coating, we get a much more even performance across completely different substrates. So they can improve both print quality and the color performance. So you're not diluting, you're not getting into color bleed, you're not blurring the lines of what is expected to be printed. And that's all comes around through collaboration required to tune the application, to have the understanding of how to, and many of these systems now, and that's why the hybrid systems are gaining traction, is if you can apply very cheaply an analog roller of primer and support that with digital print, maybe a flexo white in some cases, but digital whites now as well. It's really supporting both mono material, thin film, different substrates for different applications. We saw that pyramid yesterday of the high-end materials and the lower-end materials, and the want to switch to some of the cheaper alternatives, but maybe not being able to do that for various reasons. Well, this is something that can hopefully close that gap. And this is where we try and come in. So taking the approach, so it's not just about priming. There are additional coatings, perhaps barrier layers, all water-based, functional coatings, food contact overprint varnishes. So it's all about managing the ink, the substrate, the application, the regulatory, which is really critical now. Bringing everything together to deliver a solution for the converter that can then deliver that for their brand. So deliver through functional chemistry a solution that meets the market requirements. So where are we headed now? I think really it's pretty clear that aqueous is here to stay. I think in the exhibitions to come, certainly in Drupa in 4 years' time, you will probably see an even bigger prevalence of aqueous technology. In all the packaging shows next year, you will see, or in the coming years, you will see many more aqueous solutions. It won't be perfect for every market. I think, for example, UV in labels is doing an unbelievable job, and the growth in that market is very impressive. But in some of these harder to manage applications, and especially in packaging and food packaging, which is the dominant kind of segment within that, you're going to see a lot more aqueous inkjet application. For us, at the moment, use of a primer is allowing the technology to be adopted at a faster rate. May not be needed in the future, but for today, that interaction between substrate, primer, ink is allowing people to get the other benefits of digital that we've talked about yesterday, in terms of the short run, the customization, all the things that the brands are looking for, and we saw in those kind of surveys yesterday. And for us, partnering has really been the key, understanding the drying, the behavior of the ink with the different substrates, how it works in the printing system, the whole workflow around that. It's not just, we can't just focus on ink anymore. It has to be a total solution. What might be tomorrow? A one ink that fits all expectations on every substrate. I think we're a way off from that, but certainly that's a goal of everyone. Digital primers. They for sure are being worked on and will come. There'll be a time and a place for them. You can imagine putting anything through a print head increases the cost, right? There's a lot more risk associated with doing that than an analog process, but for sure there are systems already in the market that are doing digital priming, printing, and post overprint varnish in line, all digitally, and I expect that to come a little bit more. And will it be a replacement for UV? Certainly not. I think in some applications it makes complete sense, the transition to water-based, but in many applications UV is a perfectly safe and sustainable solution for the future, and is the right technology. And there it is again, finding the balance, understanding the application, understanding what the end user requirements, the regulatory aspects, and that there are challenges in the UV, and you will have heard about lots of reformulation that's been going on to remove certain materials, but once that's done, there's certainly a strong future for UV as well. So just to wrap up, for sure water-based inks are here to stay. They've fully emerged. Drupal was maybe the watershed moment, to use a pun, and most new applications or new projects that started come with a water-based focus. People have already made their mind up that they want to go water-based before they've really explored the application area. The pull from the market is real, and partly because these solutions are being demonstrated now. Once people see high-speed 200 meter a minute with inline drying of aqueous ink, I think that will increase the pull from the market to really go in that direction. And now it's about exploring workflows, looking at primers, interaction of ink and substrate, and how we really get that quality to the next level. But there's more to come, for sure. Better inks, I'm sure, better print heads, better processes, better adoption of digital, so that aqueous really becomes the technology of not only the now, but the future. And with that, thank you. I'm around all day. If there are any questions or you want to contact us to discuss any of this, please let us know.
Great. Thanks, Will.